2.7. I'm going to come back to the title in a second. I don't want to divulge it just yet. Just one more minute. Okay, so we talked about functions a while back when we started chapter 2, before we had our first test. And we looked at 3 different situations. This time I'm not going to put numbers in, but I'm sure you will remember these situations. What can you tell me about the first situation? First of all, I'm going to ask you, is it a function? Yes, it is a function. Question, can I go backwards and create a function? Let's see. Yes. For that reason, this function is, first of all, it's a function that is also one-to-one. In short, one-to-one. Meaning, to each y, it also corresponds 1x. Not just to each x, it corresponds 1y, but also to each y, it corresponds 1x. To each y, only 1x. To each y, only 1x. So this function is extremely important because it has that property, and you'll see in a moment why. Okay, what about the second scenario? What did we say about the second scenario? Correct. Relation. We don't even talk about it. Okay, what about the third one? It's a function, but question, is it a one-to-one function or just a function? Just a function. Function, comma, not one-to-one. Okay. Why is this so important? Here it is why. Only one-to-one functions have functions. Of course, it's the same word that I'm expecting you to come up with here. Yes. So indeed, the title is inverse functions. So only when the function is one-to-one, I can create a function that is its inverse. And you can say, okay, can you create something here? Yes, I can. I can create an inverse, but it's not going to be a function. Can you create an inverse for a relation? Potentially, but it's not relevant. But here, I could create an inverse, but it's not going to be a function. So only one-to-one functions have inverse functions. Okay, so let's look at a couple of graphs, and then we'll talk about a property here. So I created a couple of graphs, and now we know what they are. We know we identify them very easily. And you'll tell me what they are. First one. This is a review of the concepts from last time. Quadratic. Is it one-to-one? By the horizontal line test, for one particular y value, look at how many x values do I read. Is this one-to-one? Let's go back for a second. If for one y value, I determine 2 x values, is it one-to-one? No. Is that clear? For the same y value, I determine a first x and a second x for x1 and x2. What type of function is this? We know now. We are reviewing the concept from last time.
Absolute.
Absolute value. Awesome. Is it one-to-one? No. By the horizontal line test, it is not one-to-one. This one is not one-to-one by the horizontal line test. Do not confuse the two tests, line tests. The vertical one tells us whether it's a function. The horizontal one says, is it one-to-one or not? Okay. What about this? What type of function is it? Good. Look here. Is this one-to-one? No. It's not just x cubed. It's x cubed blah, 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 blah. Maybe I shouldn't write this, but the base function is x cubed. Okay, what about this? What function is this? So not one-to-one. What function is this? Is it one-to-one? Yes, by the horizontal line test. What function is this?
Square.
Yes, the square root of x, whatever shifted, let's say -4. Okay. And is it one-to-one? Yes, by the horizontal line test, it's one-to-one. Very good. Okay. Here's something that I would like to talk about next. Still about the inverse functions. Everything now is going to be about inverse functions for a minute or two. Okay. Let's create two functions that we know are inverses of each other. I'm going to give you an example, and then I would like you to create an example. Ready? Okay, just because Ben is right here in front of me, I'm going to give him my marker. Ben, you increased your number of markers by 1. And then a minute later, I say, you know what? No, I'm going to take it back. So what's the deal? I gave him 1, and then I took the 1 back. Positive, or I increased his portfolio in markers by 1, but then I took it back. Addition by 1 and subtraction by 1 are definitely inverse functions. Why? Nothing happened to his portfolio. I gave him something, and a minute later I took it back, so there is no change. Now if I give him 2, and I say, I'm sorry, Ben, I have to take 1 back, it's a different story. Addition by 2 and subtraction by 1 are not inverse operations. His x changed. It's no longer what it was before I started to deal with him, right? So can you give me an example of two functions that are inverses of each other? Awesome. If I give you $20 and in 3 seconds later or a minute later, I say, you know what, give me my money back. What was the deal? Nothing. No deal. Nothing changed in my pocket, in your pocket. Okay, perfect. So now I would like to determine the function composition of these two both ways. We can anticipate the answer. Can you tell me what the answer should be?
0.
Careful. Nothing happened. If I give you $20 and I take it back, you still have x. Indeed. That's what we expect the answer to be. Okay, so f comma g is f of g of x. See, these two sections are 100% related. They should probably be in one section. 2.6 and 2.7 are absolutely together. Okay, so then this is f of g of x. Now look at f. F says blah minus 20. How do I write that? Knowing that this is my blah now. This is the whatever. Yes. And x expected, no deal. Good. So let's look at the other one, which is, stop me if you have questions, please. G of f of x, which is x minus 20. Now it's g of whatever. And look at what g says. G of whatever is whatever plus 20.
X minus 1 plus 20.
This is the property of inverse functions. Two functions are inverses of each other if the function composition both ways, f comma g and g comma f, equals plain x, not exactly, not x squared, not x over 2, not x plus 5, just plain x. So before I write the property of inverse functions one more time, let's write the notation. The notation is this: f inverse. I know you can say, no, I know what this is, because you showed us that a to negative 1 is 1 over a. True. But this is not the case. This is the inverse function of function f. This is not 1 over f. This is just the notation. G inverse is the function that is the inverse function of g. I don't know, t inverse is the function that is the inverse of t. This is a very important notation. I like to look at this to show you several inverse functions. Here's one. SIN inverse. We do not talk about trig functions here. See, they are on the same key. One activated with the blue, with the second key, and the other one just plain. Same thing with cosine. You see next to it cosine to negative 1. It's not cosine to negative 1. It's cosine inverse. And it's not 1 over cosine. It's the inverse function of cosine. The same thing here with tangent. Also, let me show you 3 other sets. Here's one. Why do you think the square root of an x squared are on the same key? They're inverses of each other. Also, 2 other sets that we do not know anything about till chapter 4. They're right here. 10 raised to power x and log. They are together because they are inverses of each other. Also, e to the x and ln. They are together on the same key because they are inverses of each other. So 1, 2, 3, 4, 5, 6. Okay, the function and the corresponding inverse. So therefore, finally, let's write the property of You're so patient with me. Thank you. So finally, we can write the property of inverse functions. F comp F inverse and F inverse comp F, as I said, in both directions, they must equal. Indeed. Very good. This is the property of inverse functions. Final discussion before we look at some problems. Here's a question for you. I'm going to call this set A, and I'm going to call this set B, and I'm going to say that this is function f. Again, what is the domain of f? The domain of f is A. What is the domain of the range of f? B. So here's what happens, and that's why we call this, how do we call it? The inverse function. What is the domain of the inverse function? What is the range of the inverse function? If I give you a point 2, 1, and I'll say the point 2, 1 belongs to f, can you tell me what is the point for that belongs to f inverse? Right, exactly. Exactly. It's exactly the opposite. I just swap the coordinates. That's all I do. Okay, so we're given 2 functions. Problem, let's say 7. On page 321, we're given 2 functions. F of x 3 divided by x minus 4, and g of x, 3 over x plus 4. Here's the question. Show whether they are inverses of each other. Determine, are they inverses of each other or not? What do I have to show? What do I have to determine? Say it again, Ben? Yes, I have to find f comma g and g comma f. Exactly. And see whether they equal x. If they do equal x, what do I conclude about f and g? They are inverses. What if I determine that f comma g is 5x? Do I determine g comma f? It would be a waste of time. Okay, so let's start. So we want to find f comma g of x. A lot of writing again. Which I know it's f of g of x. Okay. Then I cross out the g of x. Of course, you shouldn't do that. I do it because I'm trying to trigger your memory. And now, what will be the next step? So it's 3, indeed, because f of x says 3 over whatever minus 4. This is my whatever, so it's 3 over x plus 4, but minus 4. Whatever is this? Minus 4. What do I do next? The numerator, remember, is 3 over 1. Everything over 3 over x. I copy the top, and I multiply by the x divided by 3. That's how we divide two fractions. I simplify, and look at that. You have to show the other one, but by now we can conclude they are inverses of each other. But we have to find the other one as well. So we have to find g comma f. Ready for g comma f? Any questions? Of course. Oh, sorry about that. So far, so good? Okay, so then g comma f, g of f of x, 3 over x minus 4. And now carefully look at g. G says three over blah plus 4.
So would you put blah instead of this, or would you just write it?
There is no need because I have 3 over. Careful where you put the fraction line. Over 3 over x minus 4. And then next to it plus 4. I have to perform the division first. And this is 3 over 1 for sure. I write 3 over 1 and then x minus 4 over 3 and then outside plus 4. Any questions so far? Okay, so obviously I will not ever multiply, I will first simplify. And then I get that x minus 4 plus 4 is indeed x, which I knew. Once this one is x, unless I made an error, of course, the other one has to equal x for sure. But now the question is, what do I write? Are they or they're not inverses of each other? Yes. So F and G are inverses of each other. Indeed. I know I have 9 minutes left. I'm debating with myself whether to look at a word problem first or graphs. A word problem? Yes? Graphs? Okay, very good. So let's look at the graphs. Here's a graph and a word problem at the same time. Okay, so let's read the question. The graph represents the probability of two people in the same room sharing a birthday as a function of the number of people in the room. So the function is f. What does this mean? So we are, let's say, 15 people in the room, and there is a great chance, or there is a chance, I shouldn't say great, there is a chance that two of us are born on the same day and month. We're not talking about year here. We're talking about same day, same month. So there is a chance. How many people should be in the room for a certain percentage? Let's say I want to make sure that a 90% with the probability of 90%, 2 out of a certain number of people share the same birthday. Okay, so I can do that. So what happens here? This is the number of people in the room, and this is the probability that 2 people share the same birthday, month and date. I wanted to erase the pencil so I can do it again with you. And where is my pencil? But I had it right. Oh, I got it. I found it. Sorry about that. Here it is. Okay. So the first question is asking us to, does this function have an inverse?
Yeah.
By the horizontal line test, this function has an inverse. It's 1-to-1. By the horizontal line test is 1-to-1. It has an inverse. Describe in practical terms the meaning of f inverse of 0.25. And how do I determine that? So this is function f of x. I'm not asking to find f of 30. Well, f of 30 will have a probability that 2 people in the room share the same birthday of how much? 70%. Very good. No, I'm asked how much is f inverse of 0.25? Where do I start? Exactly. I start at 0.25 with a horizontal line. It meets the graph in whatever, and then I read how many people should be in the room in order to have a probability of 25% that 2 of us share the same date, a birthday, month and date. So how many people should be in the room? So 15, according to the model. Okay, second question. F prime, so this will be 15. What about F, not prime, I'm sorry, this is derivatives, and I'm thinking of something else. So F inverse of 0.5. So we go to 0.5. So if we want to be 50% sure, right, roughly 25, indeed. So this will be 25 people. And also they want us to find F inverse of 0.7. F inverse of 0.7 should have in the room, we should have in the room about 30 people in order to be 70% certain, not 100%, 70% certain that, or the probability that 2 people in the out of 30 share the same birthday. So this is an application of inverse functions. Okay, and I will end, I promise, with just one idea here. Here's the next step. Remember we said that, thank you, sorry. Can anyone give us a linear function?
You were supposed to zoom out.
Thank you, sorry about that. Okay, so give me a linear function, a nice one.
7x minus 5.
Let's say just 2x minus 4. You'll see in a moment why. A nicer one, yeah. I want to graph this. We've read that before. We also had it on the test, graphing using x and y intercepts. I just wanted integers as intercepts. That's all. That's why I didn't use your example. It was a perfect example. Nothing wrong with it. Okay, so I want to graph this. So when x is 0, how much is y? Very good. Can you give us the first ordered pair, which is the y-intercept? Okay, so now I want y equals 0. Move 4 and divide by 2.
2.
Excellent. What is the other ordered pair?
2 and 0.
Perfect. I'm going to go to the next page. So you helped me determine 2 ordered pairs. Excellent. And they are 0, -4, and 2, 0. Remember, as I said, please, always, whatever you graph, write somewhere next to it its name, above, below, left, right, anywhere you want, but please write its name. Okay, perfect. Now, we know that this function has an inverse. We know that because it's 1-to-1. I don't know the inverse. I have no idea. I don't have time in 2 minutes to show you how to determine. We'll do that on Wednesday. So, exists, comma, I don't have it. It yet. Okay, so I don't have it, but I want to graph it. And you can say you don't have a function and you want to graph that function. Yes. I would like you to give me exactly 2 ordered pairs that will help me graph that function.
-4, 0.
Of course. Of course. Remember what we said? Exactly. Just change the order. So indeed, -4, 0. And 0, 2, indeed. Now, before I graph, I have to always, when I graph the function and its inverse on the same coordinate system, I have to draw this line. Can anyone tell us which line is this? Everyone knows the line because we talked about it. Was the first function in transformations. Very good. You see where this original function crosses that line? Can you think of what this point could be? Of course, we have no clue. But just give me a possibility. Comma. Excellent. 5, comma. Of course, because it's on y equals x. So because it belongs to this graph, it will automatically belong to the other. Reverse 5, comma 5. What do you get?
Same.
The same thing. So it must be and this is F inverse that I don't even have. I have no idea what it is. I will.